Okay, so everybody should be able to see and hear me.
Yeah, okay. At least I
Good.
can see you and hear you. I think we're okay.
Nice.
Okay.
So, welcome everyone. I know this is an early session and it's like a bit of an intriguing and niche topic, but I think it will be worth your time waking up early and joining this call. So, a
Okay,
little bit about me.
Christos, sorry to interrupt you. Everything will be recorded anyway, so they will be able
Yeah,
to follow the sessions and afterwards. Okay. Sorry about that.
nice.
You can go,
No
yeah.
worries. So a little bit about me. I'm a solution architect, and I'm also a Microsoft MVP in the areas of DevOps and infrastructure as code. There are, let's say, the endeavors that I take with the community in the MVP are various. I have a blog that I regularly, or at least I try to regularly contribute to. And I also have GitHub where I have open sourced some tools that relate with infrastructure as code, for example, Bicep docs to generate documentation for Bicep, some template repos around Terraform and Bicep, and some other template repos with KQL, cooperating with other MVPs like Michalis Michalos. If you are from a security background, I believe you're familiar with him. So yeah, I don't want to waste any more time about the introduction. I think today's topic is like pretty interesting, and it might not seem that way from the title. Policy-driven governance for infrastructure as code. Can I already achieve this with the tools that I have in place? And we will see that the approach that I'm gonna demonstrate today, it's like taking it to the next level. So let's set a bit the stage. I believe we're all pretty much, we're not talking about governance and infrastructure as code, we're talking about as the same thing, meaning what? We want to govern infrastructure as code, both from the development point of view, meaning that as with application code, we can ensure that all things being developed follow some standards, etc. And also, before applying that infrastructure code, whatever that code might be, it could be Bicep, it could be Ansible, it could be Terraform. Before applying that code to our infrastructure, we want to make sure that the changes that will take place are in line with the requirements, the restrictions, the standards that we have as an organization, as a team. And what are some common pain points that we see with the infrastructure as code adoption? It's like it's easy to start and experiment, but as time progresses and you try to do even more operations through infrastructure as code, it gets a bit complicated because you have a lot of environments, you have a lot of projects, and the risk of misconfiguration increases because of the complexity. So that's where the policy enforcement ensures that these configurations are detected early. And besides the detection, one important thing that we also need to consider is to give feedback back to the person developing the infrastructure as code. Because saying that, okay, this module that you have written does not comply with 5 of our policies, but not doing it in an organic way, meaning where the developer works, so they can take that feedback and go back and fix the code, that just adds friction and, let's say, latency to the whole delivery cycle. Another thing that it's common is like we don't have any centralized policy library. So we don't have a unified baseline in terms of what are our security controls and how they get applied. Now, of course, like I said, the concept is not to have one baseline to rule them all, but you should start from common points and then differentiate across teams with different maturity, different criticality or environment. For example, the policies of a dev environment, of course, cannot be the same with those of a production environment. And overall, without making policy enforcement and shifting it left, like we have done with various other things, it's difficult to scale and truly adopt the infrastructure as code model of operations when it comes to infrastructure provisioning. Now, what is the policy-driven governance with what's policy-driven governance with policy as code? That's the difference here that I want to make, because you might already be familiar with concepts like Azure policy, or I don't know, other platforms offer their own policy rule set. What's the difference of having a policy-driven approach but doing it via code? Then you don't have to rely to a lot of manual controls, but I think a lot of us already passed that stage, perhaps not always, but it's like we try to get the best of code. Like, why did we move from doing manual things with our infrastructure operation and doing them through code? Exactly the same premise, having that auditability, having that automation, having that capability to reuse components. That's also why policy as code has emerged and is like gaining traffic in this whole as code paradigm, because we're doing a lot of things as code nowadays. So the concept is similar. We are writing our policies as code, and we can automatically enforce them whenever a resource is defined or modified. And this can make things proactive, because think of it. If you have a policy as code, you can integrate it into a CI/CD pipeline that perhaps deploys your infrastructure, as we will see in an example later on. And before that deployment takes place, you can provide feedback to the developer that triggered that pipeline, what's wrong with their code, policy-wise. So this is an organic way to integrate the policies and the rule sets and the restrictions that you have as an organization that might be org-specific, not a generic baseline like the well-architected of Azure. You might have org-specific policies that you want to apply. That's not as simple as, let's say, okay, don't allow public IPs in a VM. It might be, okay, when this happens and this happens and this naming convention, I don't want that to allow that. And you need to have a way to express that. So what we would want to do, because oftentimes it helps defining first the target state and seeing how can we reach that. We want to have proactive governance. Like I said, we want to detect all the issues as early as possible, shift left, and provide feedback so they can be resolved, and the feedback loop and the delivery cycle can be reduced. So this ensures a better experience both for the stakeholders that define all these policies, but also for the developer that has to comply to them, because it's important to take into consideration the person that's going to be developing the code and how early or late you give that feedback that they need to make changes. We have the capability for automation, like I said, with the workflow integration into CI/CD pipelines, and the complexity there can be as complex as your approach is in CI/CD pipelines in your organization. It could be for something simple to something like having quality gates that depend on these policies, triggering them on pull requests, etc. And this way we can automate and scale. We can create, as time progresses, a library of policies that keeps getting enhanced and can keep getting reused on various scenarios in the future. Now, here in this presentation, I'm going to recommend the tool because it would be like impossible not to do so. And the tool that I believe is one of the best candidates to achieve the desired traits that we just talked about is the Open Policy Agent. Now, if some of you are from a Kubernetes background, you might know about Open Policy Agent and Gatekeeper. But essentially, Open Policy Agent is an open source general purpose policy engine. It has been adapted by the Cloud Native Foundation, and its whole purpose is to enforce policies across different systems and environments, and to do so in the most flexible way possible. So, if I try to, let's say, describe it in one sentence, it would be that the policy engine, what we mean about policy engine, we have an engine that processes the policies, receives some input, and gives you feedback on whether the input that you gave is compliant with the policies or not. That's like the very simple way of describing the policy engine. So what it does, it processes data in native formats, in formats that it's possible for it to process. And it has a language, its own language, which is like the Rego. And that's the way that you express and describe and develop all your policies. You do it through Rego. So you have some different concepts. You have the programming language, Rego, or the policy language, whatever, which is how I express the policies. And then I have the policy engine, which is like how I evaluate these policies alongside an input to see if that input is compliant. So it provides a reusable framework. Why? Because you can separate, you can have a separation of policy enforcement. You can have policies that relate to application development. For example, you might have, depending on the stack you're using, some configuration files, some feature flagging, some stuff that relate with your application. You can have policies there. Then you can have your infrastructure in terms of Terraform plans or bicep or configurations. You can have your policies there. You could have like scripts or Ansible playbooks that patch VMs, automate stuff. You can have your policies there. Essentially, you can have your policies, as we will see, into every single tool that's able to produce one of the native formats that Rego supports as input and Topa supports. Now, let's drill down a bit on how it works, because I think it's really interesting. It has a bit of a learning curve, but trust me, if you dedicate the time to understand it, you will realize like the capabilities of it are unlimited. So you have services that run. Like I said, it's not meant, we're talking here about infrastructure code, but let's be more general, whatever code. You have some services that will run, and we need to evaluate a policy to see if something is compliant. We do so by running a query. It's the same premise in the data world. I want to ask something about something. I perform a query to learn about it. And then OPA determines the policy's decision. When we're talking about decision, we're talking if it passes, if it fails, the evaluation essentially of the query against the data and the policies that it has. So it's like I have this huge rule set of mine, which is policies and data, because you might have a policy that relates with another data source. And then I receive an input, a query, and I'm responsible as a policy engine to evaluate whether that query is compliant with the policies or it's not. So this, I believe, this diagram and this case, it's like really useful and really simple for somebody to initially understand how OPA works. So the decisions that the policy engine provides, of course, relate with the policies. And these do not have to be only yes and no, or allow and deny. Depending on how you write your policies, you have the flexibility to support multiple scenarios, however complex. Of course, you would start small. So the whole concept is that we have a request that's incoming, an event, something to trigger the policy engine with an input. Here is the input, any JSON file, and that's like where I wanted to come to. I talked about native formats of OPA. OPA, as long as you can express your input in JSON, it can handle anything. And nowadays, with a lot of tools that we have, I think JSON is the easiest format to transform your files to. So, for example, think about it, and we will see in this example, we will see it in a live example later on. A Terraform plan, of course, has like the Terraform configuration, but it can also be converted into a JSON file. A bicep module can also be converted to an ARM template, which is a JSON file. An Ansible playbook, which is YAML, or a Kubernetes manifest, which is YAML, can also be converted very easily. YAML to JSON conversion is very simple. And similarly, whatever config file, because it's going to be like in a semi-structured way, that's what we're talking about. We're not talking about free text. It might be XML, it might be TOML, it might be whatever, can most likely be converted into a JSON file. So if you convert it into a JSON file and feed it into OPA, you can have policies developed for it. And as you can imagine, this is really powerful because, like I said, almost everything can be converted, almost all config files that are semi-structured, whatever the format, can be converted into a JSON value. Then we have the policy engine, which, like I said, combines the policies that we have written, which is our specific logic on what we consider compliant, what we want to pass, etc. And this happens by leveraging the JSON schema. So you can think of it, and we will see it like I know the JSON structure, of course, and I'm just accessing fields and saying what values I want to be there or not to be there with a simple dot notation. And then we could have some data that can also be in JSON. It would be helpful to think as data is giving a bit of context. So you might have a policy that relies on something else. It's not like a straightforward if this or that, yes or no. It might be, okay, if I receive this and this happens at the same time, then no. So you need to have that data, again in JSON, to give context at some cases. And then after the evaluation happens, OPA returns with a decision. The decision could be any JSON value. Like we said, it does not have to be yes or no, or accept, deny. It could be various stuff, depending on how we have structured our logic. And like, think about it, like the integration opportunities here are so many, because you can, like I said, even if it is software development, if it is infrastructure as code development, even if it is whatever it is, almost everything where you need to apply a policy. Again, we're talking about policy. We are not trying to replace things like static code analysis in application code or linting. We're talking about policies. Can be expressed in JSON, so you can support it essentially. And if you see here, like, Copa is very well established in the Kubernetes world with Gatekeeper as a policy engine. And I think, and from my experience developing, it is a real powerhouse that can be leveraged as well. And that's why I want to also demonstrate today here how it can be leveraged in the infrastructure as code world. So like you see here, you have the requests that are incoming, and it could be whoever that does this request. Most probably it would be like an automation flow, either a pipeline or a script or somewhere that we want to take action with the code and the config files that we want to evaluate. And then you see we have like the service integrations that have with Opera unlimited. Essentially, it has this here with Terraform, Docker, Istio, GraphQL, whatever. But if you want to baseline it and make it as simple as possible, any JSON file can work. And again, we give the query, we have our policies and data, and we give back a decision. And based on that decision, we can take action. Now, what action could that be? It would be as simple as failing the pipeline or not, or it could be complicated, like based on a score that returns from OPA, I can escalate and notify particular admins, do whatever I want. It's meant to be flexible. So let's talk about infrastructure as code specifically. So we can see, let's say, also some hands-on example. The key points to consider when you are trying to, let's say, govern infrastructure as code using OPA, it would be like OPA has this concept of a library, which is like very common across various things that we do. It's the same as having reusable modules in Bicep or Terraform. We have a library of policies that we want to reuse. Of course, this policy library, we want to perhaps version it, store it somewhere remotely, so various actors can have access to it when we need the evaluation. Otherwise, you would need to have, let's say, on the same VM or on the same agent that runs, let's say, the pipelines, the policy bundle locally, which, as you can guess, is not like the most friendly way to approach it. So you need to store your policies in a remote location that it's accessible from the various use cases that you have. And then the important stuff is that when you have these policy bundles, that's how it calls it, a bundle is a collection of policies, you can have your own approach, whether you want to have like one policy bundle with various subcategories, or if you want to have multiple policy bundles targeting different scenarios. And then, like I said, we will store it in a repository or server. For the Azure side, what I found most effective is like Azure Blob Storage does a pretty good job, meaning that what we're storing essentially is a policy bundle, which is like a collection of files. It's not something very sophisticated by themselves. When the policy engine loads this file and takes decision, then it becomes really useful. But by themselves, it's just a collection of files. But you could also store them in S3 in Amazon. You could also store them in container registry in GitHub, in Azure and in the GitHub container registry, as long as the registry is marked as OCR with the Open Container initiative. And then you can easily integrate those things into your workflows. Now, this could be like an example architecture where I have my policy library, which is simply, as we see here, a Git repo, nothing complicated. I have a workflow that pushes my policy bundle into a registry. Here I have the container registry. You can pick and choose. There are a lot of repos that you can do so. And the official documentation states that from OPA, so whatever suits you. And then you have, let's say, a project X, which will be our victim for today, with whatever infrastructure code you have, like it would be Terraform, Bicep, Ansible, whatever. And then we have a deployment workflow. to execute that playbook or deploy that bicep module or Terraform module. And in that workflow, we essentially are going to pull the bundle from our registry, run the policy query, like we said, and this is going to provide us with an output of whether the code defined in project X, depending on stack, is compliant or not with the policies that we have defined in our bundle. Most likely, if it is, great, move on to the next stage of the pipeline. If it isn't, we can fail. And the good thing, as we will see, is like when you define the policies, you can also define the message that you want to showcase if like a policy is not being met. And that's why I stressed feedback in the earlier stages. You can imagine that having a developer that writes a Terraform module or an Ansible playbook and they try to trigger the pipeline, perhaps the pipeline is not necessarily to deploy. It could be a CI pipeline for infrastructure as code. And the policy bundle runs and comes back with feedback, okay, these two policies failed, here is why. That's what's expected, and that's why it failed. And it's very easy and quick to go back and update your code in order to be compliant. So it makes sure that make sure that yes, my requirements are being met, yes, my standards are being met, but also I don't make the life of the people that are going to develop the code harder. I make it easier. So regarding the policy library, here's like how a possible structure could look like. You see, we have like this is the repo. And essentially, when you have a policy library, you have one big folder called policy. And this, what I'm talking about now, it's like the idiomatic way to do it or the standard way to do it. Of course, you could have whatever you want. It's not required of you to have this particular format, but it's very helpful. And there's no clear reason why not to do it. Then you would have your tool as a first level differentiator, for example, Terraform. And then you can have like a nice subdirectory of things that you want to check, depending on the tool, of course. For Terraform, you could have some helpers, and you could differentiate on resources. That would be useful, because Terraform has this concept of resource, and it makes sense to follow that concept when you are writing policies. And you don't need to combine, if you have the full policy library, you don't need to combine different policies into one file. So let's say I want a policy that relates with public IPs, and I want another policy that relates with the naming convention of particular resource. I don't need to have them in the same file. As long as are in this policy bundle, that's okay. Both will run and are different policies, so it makes sense to keep them separate. And then you can, if you want to only, let's say, evaluate against a particular policy, OPA has this concept of namespaces. And that's why having a clear directory structure helps, because we can access those namespaces like with a lot of programming language by just having the dot notation. So it could be like Terraform dot Azure RM, the provider, dot, I don't know, virtual machine. And then you are saying, okay, I care about only the policies that are in the virtual machine package. It can be however many you like. And also another convention is to have like a test file of the policy with some example or dummy data of yours to validate that, okay, the policy that I have written actually works. And we will see it's really easy to demonstrate that. Here are some policies. Now, I'm thinking perhaps let's do with code. No need to showcase that from there. Let me open up here. If it's still very small, you can say, and I will zoom in. I like to work a bit on a zoom out. So you see, let's say the source. The sources are code, and here we have the policy directory. You see here we have like the tool that I'm going to demonstrate this example is Terraform, because like it's, I believe all of us are familiar with Terraform, and it's easy. And you see this differentiation that I have. The provider as a top level. For me, the provider that I'm going to demonstrate today is the one of Azure DevOps. I have some generic helpers. This can be used across providers. And then under the provider, I have the resources that I want to write policies for. So these are the actual resources that if you see a Terraform module, I try to keep them the same as convention. So you can think of this as a good practice. This is something that I like to do, but it makes it clear. So it's like Terraform, provider name, resource of the provider. So it's very intuitive. And the reason we want it intuitive is because when we write the policies, that's what we're going to query. So if I open here and showcase to you how a policy file looks like, this is one policy file with Rego. So I define here some metadata, and this metadata description is very useful if you follow that format because it gets picked up and you can see it you can see it printed when it provides feedback if you follow this convention. And I define a package. The package that I define here is like I said before, Terraform, provider, the resource. So this helps me if I want to just query policies under that particular namespace. Because imagine that you have an extensive policy library with a lot of provider and a lot of resources. You don't want to query, if you have, let's say, if you're deploying something to Azure DevOps, there is no reason to query and evaluate all the policies that you might have developed for Azure or AWS. You just want all the policies in the Azure DevOps namespace. And even if you're deploying one particular resource, let's say you're just deploying a Git repository, why query all the policies of Azure DevOps? You just care about the Git repo. And then we import the V1. This is like a generic package that we want. I don't want to go into too much detail here. I just want you to get the idea. All these are available in the documentation. And here we're defining the input. This is like the input that we're going to receive, like we said, the file. And for us, the file is going to be a Terraform plan. So if I open this up, this is a Terraform plan. This is how it looks like. And I need to know how it looks like. Why? Because OPA won't guess for me the format and how do I query this file. It just provides all the tools for me to go ahead and define policies for this kind of file. But I still need to be familiar with this structure. Now you're going to say to me, do I need to know by heart every single Terraform file? No. Most Terraform files look the same. And that's why you develop some helpers once you do it once or twice. So you can just use the helper and not have to learn it by heart. What you need to know is like the name of the resource and of course the fields of the resource that you want to enforce policies to. So if we go here in the Terraform file, this is copy paste from the file. This is like the output of Terraform. I have not modified anything. What you mostly care about when you're defining policies is this field, resource changes, which essentially describe what is going to change. Because a Terraform plan might be about creating something new, but it could also be about modifying something existing or deleting something. So what you care about is resource changes. And if you see here, you have the resource changes, you have the type. So this is like the resource that we care about. And then you have the actions, which is create, before, after. So a really common pattern that we're going to see today is like, for this resource, the after field, I'm care about what will happen if I take this action. This is after means what will happen after I apply the Terraform plan. And this is are like the fields. So if I go back here and I showcase you the helper for resources, you see this is a package, a set of helper functions to filter plan resources. So I can quickly get those values instead of having to manually ... all the way to that particular use. So I have a function here that's called get resources by type. And essentially what it says is like, for every, this is a selection of resources and this is a type. For every resource of type this, bring it back. And if we go back to the Terraform plan, you can see we have this type field. I'm not imagining it. Similarly, by action, we have this action here field. And if you see, I'm going resource.change.actions, which is like resource, this one, object, change, actions. And similarly, I do by name. I will just showcase this because this is like perhaps one of the most important ones. I want to get resource by name. And what I mean by name, I mean I want just the Git repositories. How would I do this? I just filter This is like to filter an array, the syntax, resource.name. And I have here the name. So it will be resource name. So if I want to get all the Git repositories in the Terraform plan, what would I do? Get me all the resource changes. You see here, this is the TF plan as the input. This is the top level of the Terraform JSON. I want the resource changes field, just this one. I get it here. And this is with if I had not the helper, the example. And for every resource change, if the type is this one, I check the valid name. If we see with the project, you see I have this helper that I'm calling, and I'm inputting it from my resource from my resources helpers. You see data. This is where the data we talked about, which is giving context. Terraform helpers, and I'm saying, okay, here what the policy looks like. This is a deny policy. I would recommend everybody, there are two schools of thought. The one is I want to define all the things that I am going to allow. But as you can imagine, thinking of all the things that you want to allow is really hard because you have to think about all edge case scenarios. Whereas thinking about all the things that you don't want to allow, it's much easier. So what I recommend is starting out by saying, okay, all the policies that I'm going to define are going to be the things that I don't want about this particular resource. So for an Azure DevOps project, I have here 3 policies, 3 rules, essentially. And you see here the metadata, the title. The first one is deny the creation of Azure projects with visibility other than private. So if I try to create an Azure DevOps project through Terraform and it's not private, but it's public, this should fail. And we see here, deny if. It's very simple, the syntax. Once you write one, it's like the same for all others. Deny if the following conditions are being met. And we say, okay, get by type, get all the resources that have the type of Azure DevOps project. So here, because the type is Azure Git repository, it would not select this particular resource. We don't care about it. And then we see, we query the field like this. If after, because we have get a resource, if the change after and the field that's the visibility is not private, it will fail. That's all we need to do. So if the conditions are true here, which is like this different, we will deny. And this simply is like a way where I copy paste it's to provide the description if it fails with the description that I have here in the annotation. If you see annotation.description. Exactly the same. Let's say we want another policy, not to allow TFS. We want to allow Git repositories only. Copy paste. We modify the title and the description because, like I said, these are meaningful to give feedback when the policy fails. And we say, okay, the change after a different field here, the version control is not Git. And for the final one, which I have also applied to a lot of clients in order to ensure platform uniformity, it's like I want to deny the creation of Azure DevOps project with invalid names that does not respect the naming convention. And this is a particular scenario that I have a logic, my own logic, an organization logic, a team logic, which is I have a naming convention in Azure DevOps for project and for repos, but the platform itself does not allow me to enforce it. There is nowhere that when I go and create a repo, a particular naming convention can be applied. So the only way to achieve it would be what? Use Terraform with pipelines to create that repo through Azure pipelines, which is like exactly the same number of clicks that you would do, but have this policy in place when the pipeline runs. So this way I can very easily, once I set it up the first time, for all new repos and all new projects, ensure that the naming convention is being met. And if I just showcase this once more, I get the resource by type. I only care about Azure DevOps project. And if it does not have a valid name, this will fail. And this valid name is a helper function, which says, okay, this is the regex, this is the length that I want to allow, this is the length that I want to allow. Now, what would the test file look like? Test case is simple. I want first to test the private visibility, if it will pass. And I give the input myself. Let's say, mock the Terraform. And I just mock it, I don't need to mock this whole plan. I just need to mock the fields that we're going to be testing. So with input as resource changes, type Azure DevOps project, change after, visibility private. So here essentially I have mocked one project with private visibility. I want the deny count to be 0 because I want it to pass. If I give it public, I want the deny count to be greater than 0 because I want it to fail. And similarly, I'm testing and I'm also here testing the visibility message. Now for the Git repo, which I also have this Terraform plan to run it for you live, I have just one rule, which says, here I'm not using the helper on purpose to showcase how you would do it without the helper. It's not that much as a change, but having to do this every time for every resource, it's cleaner, I think, having the helper. And it does not have a valid name. What is a valid name? I describe it here. It starts with a letter, it's followed by letters, and etc., etc. So we're gonna run this Terraform plan. Actually, So if I showcase, here is like the tests. Go to source. So you see here, I run the test. So I'm essentially saying test the policy directory for the Git repository resource, this namespace. And you see, these are all the tests that I have. Now, if I want to run my policy rule set against this Terraform plan that I showcased here, which will create a new repository. And if we see here the name, let's call it library module initially. This name is compliant with the naming convention that we have. So if I run this, and you see I'm running test, I'm specifying the namespace. If I don't, it's also going to run the project rules. They're not going to find any because, like I said, they filter on the resource. But if you have a very big policy library, why introduce that level, let's say, of latency? It might be much, it might be not. And then we have the policy library and then the input, which is our Terraform file. So if I run this here, you see it passes. Everything good. Now let's open this and find a rule that will not. Okay, it needs to start with a letter. So let's start it with a number instead of a letter. And we rerun this. You see it fails. And it fails, and it tells you, it has here the description which says Azure DevOps repository names must be between characters long, do this, do that. All this description is this description that I have over the rule. So you can imagine that the lifecycle development is very native because the description of the rule and the feedback and the error message that's going to be provided to the end user resides exactly on top of the policy itself. So it makes it very easy to maintain the lifecycle. And yeah, here it is essentially. Now, I don't think it's meaningful to showcase here the CI. Yeah, no. Essentially, what I want you to understand is this is a very simple scenario, but a valid one with Azure DevOps project and repos, where I have a need to express a particular logic of my organization or of my team. The platform does not allow me to. And this is a very nice way that I can do so. And you can imagine that you can go wild with this. You can write your own policy about not just Terraform, but Terraform is very good candidate, but for other tools as well, for many resources, for various scenarios. And as long as you're familiar with this, with the JSON layout of the file that you're gonna evaluate, which is like as simple as getting one of them, studying it a bit, and creating some helpers to have them for the future, you can have like a policy framework that's agnostic to anything else. It's just a simple Git repository, and I'm pushing this bundle, this folder as a bundle to a remote storage. And other than that, I can use it however I like. So I think this is really powerful. And here is like how it would look in an Azure DevOps pipeline after you have run this. You see here, I did not specify any namespace, so it ran all the policies. And you see 3 policies in the namespace, the project, 1 policy in the Git repo. So if I was creating a repo, of course the policies in the project and other stuff will pass because they filter on that type. That was a lot of info. I just I find this very interesting, to be honest. And if you allocate some time for the initial learning curve, essentially you have a tool that you can apply whatever custom logic you have in your organization via policies. And here I would like to mention that this is not meant to replace existing policies like Azure policy or check or stuff like that. It's meant to enhance them. There's no reason to go and rewrite all your Azure policy rule set into OPA at all. Instead, you should focus on things that cannot be expressed by this kind of tools. Because this kind of approach, and that's why I like to call it a framework, a policy framework, it's agnostic to, let's say, technologies or stack. You can use it across the landscape as long as you have an input JSON, which I think it's like a very simple condition to comply to. So very fast on good practices because our time is ending. Follow the single responsibility. Like I said, all the policies can run. Keep them by resource or by your own categorization, but try to keep them modular and small. There's no reason to have them in a huge policy file because if you want multiple policies to run, select all those namespaces. No reason for you to try and fit them. Write tests. It's simple to write tests, but it's very helpful to ensure that everything works smoothly. Have a modular design. Optimize performance. Optimize performance meaning what? When I query, I want to query on this part on the namespaces that I care about. No reason for me to query across the whole library. And I regularly review and update your policy rule set. So key takeaways for this. It's important to have governance. I believe we are all, let's say, aware of this. And in order to have a governance framework that we don't need to change every few months and have it flexible because the tools that we are using might change. So we don't want to have a dependency on the tools. I believe OPA offers a solution for that. And most likely, if you are using Kubernetes, perhaps already they are using OPA in their cluster. So you have like also a unified baseline when we're trying to express our own logic for policies. So yes, I would say that sums it up. I tried to make it interesting to you and trigger, let's say, pick your curiosity to go ahead and search it out. I will try in the following 1 or 2 months to also create a GitHub repository as a public template, which has this kind of structure and examples, so we can quickly start from it and tweak it and modify it and play around it. And so you can start developing also your own rule sets. So yeah, thank you for joining me this early on a Saturday morning. I hope you found it useful.
Thank you, Chris. Early in the morning, Saturday morning, very early. So if you have some questions, you can use the chat here in Teams. So let's wait 1 or 2 minutes to see if we have any questions. So let me check. So I want to mention to all attendees that everything will be recorded, so you will have the option to check again all presentations. Okay, I don't see any questions. So Christos, thank you very much. For all the other attendees, you can stay in this room or you can change room if you want. The next speakers are at 10 o'clock in 15 minutes. Okay. Thank you all and see you in the next one.